All right, so we're going to take a look at graphs of various logarithmic functions. In this section, we're just looking at identifying the domain of a logarithmic function and graphing those logarithmic functions. So here we're going to start out by looking at e to the x, and then the inverse function, natural log of x. And so we know for exponential functions that domain is going to be all real numbers, so negative infinity to infinity. And if we plot some points on here, we know e to the 0 is 1, e to the 1 is about 2.7, and then we just kind of go up from there because we don't really care exactly what the points are, except that it shouldn't go up like that. So let's try this one last time and then we'll call it a day because I can't draw lines. There we go, close enough. Right, so there's our y equals e to the x. We know that it has a range from 0 to infinity, and we know it has an asymptote that is the x-axis, i.e. y equals 0. So we know for the graph of natural log of x that the range is going to become, the range of e to the x is going to become the domain, so 0, infinity, and the domain of e to the x is going to become the range of the inverse function, so all real numbers. We also know that the asymptote should be, instead of y equals x, it should be instead of y equals 0, it should be x equals 0, which of course is the y-axis. Okay, so we have the point 1, 0 on e to the x, so we'll have the point 0, 1. We have the point 1, 2.7, give or take, so we'll do that there. And then we'll just kind of sketch in our graph close enough. So there's what our log function roughly looks like. Okay. So most of the rest of this chapter is about doing transformations on logs. So we've gone through a couple of rounds of transformations now, and this works exactly the same way. We want to know, so for this one we're going to do log base 3 of x minus 2, and we want to know, okay, so first off, what are the transformations that have been done here versus the base? We're going to consider our basic log function will just be log base 3 of x. So we see immediately our transformation is that the input's been changed from x to x minus 2, which means that we have a horizontal shift. And really the primary thing is that we've moved right 2 units. So we could say, okay, well, I know my general shape of a log function is going to look roughly like that, but we know a couple of points, right? Log base 3 of x, anything to the 0 power is 1. So 1, 0, we would have 3, 1, we would have 9, 2. We know these points, right? Because log base 3 of 3 is 1, right? 3 to the 1 equals 3. Log base 3 of 9 equals 2. 3 to this 2 equals 9. So this, if I can get it close enough, put some shading in there. All right, so this blue function is going to be our y equals log base 3 of x. And then if we're shifting this whole thing to the right by 3, so we can just say, okay, well, so 1, 0 is going to become 4, 0. 3, 1 is going to become 6, 1. My asymptote that was at x equals 0 is now going to be, oh, sorry, we were going over 2, not 3. So we're going to be at 3, 0, and we're going to be at 5, 1. And then we would be at 11, 2, but that's off the screen. So our asymptote, instead of being at x equals 0, is going to be 2 over at x equals 2. Our range is still going to be all real numbers, right? Because our graph is going to look like this. So it's a very slow growing graph, but it goes all the way down to negative infinity and will eventually reach positive infinity. But our domain is shifted, right? It was 0 to infinity, and now it's shifted over to 2 to infinity. So, and again, these are all kind of self-checking. We can always graph them and determine what's going on. Before we move into this next one, we'll take a break so that these videos don't get too long.